Okay. So first topic in this chapter. So we have done 8.1 on a Monday. Okay, so 8.1 is very similar to your chapter 2. Okay, which all of the questions can be solved by using Z4 equations. The only difference is you have to transform the variables from U, V, A, F into omega naught, omega, alpha, and theta. Okay, so before we proceed to 8.2, today's topics, we are going to go through the introduction first. First thing, chapter 8. Chapter 8 is a rotational of rigid body. So you have to know what does it mean by rigid body. A rigid body is an object with a definite shape that doesn't change. So the shape is fixed. For example, a table, the shape cannot be changed, and so on. So what is a non-rigid body? So for example, liquid. So liquid, the shape is not fixed. That's why we cannot call it a rigid body. So the rigid body, there are plenty of things that we have around us. So the motions of a rigid body can be analyzed in terms of translational motions and also rotational motions. So the meanings of translational motions is linear motions. Okay, we've seen on Monday as well. Translational, it has another meaning called linear. So for every moving object, we can analyze it in terms of a linear motion and a rotational motion if it is rolling about the center of mass. So as shown in the diagram, okay, the object, it can move in a straight line and it can rotate at the same time. So a typical example in our real life is the car, a moving car. So why a car can move? Because of the tire, okay, the rolling tire. So when the tire is rolling, it's moving, it's turning, the car can move in a straight line. So it is a combination of translational motion and rotational motion at the same time. So this is another few examples that involve a rotational motion combined with other motions. So for example, the Earth. Earth is circulating, is orbiting the sun, okay, and at the same time, it has a self-rotation. So this Earth is moving with rotational motions and circular motions at the same time. It's orbiting, which is a circular motion, and it's rotating by itself on its own. So this is another rotational motion. So this is what I mentioned just now. It's moving in a straight line, okay, and it is rotating at the same time. So usually this is happening on a rolling object. Any rolling object, it has two motions at the same time. It's moving with two different motions at the same time. So before we proceed to the calculation, there's another one very important term that we have to know, which is known as axis of rotation. So in the simplest kinds of rotations, points on a rigid body move in a circular path. The center of all such circular path is defined. It defines a line called the axis of rotation. So if you look at this diagram, okay, so how are we going to analyze the rotational motions of an object? We are not going to look at the whole object. Okay, we are just going to select one point on the object. So basically, we are just going to look at one particle that makes up of the object. So for example, if you look at the thumb of this person, then we are just going to analyze the rotational motion based on this thumb, this particle. So when it completes one round, okay, when this person rotates one round, these particles actually it complete one circular motion, one cycle. And the center of these cycles is the axis of rotation. So that is how we define, that is how we determine the axis of rotation. So if you look at the shoulder, if we want to analyze the motion based on the particles on the shoulder, so after it completes one rotation, these particles, it completes one cycle. So the center of this circle is the axis of rotation. So when you join all the centers of the circles together, it forms the lines of, these lines known as axis of rotation. Okay, so based on this diagram, it takes the thumb and then shoulder and another thumb to find out where is the axis of rotation. So you have three cycles. When you join their center together, it forms a straight line. And this is the line that we want to use in our calculations after this. So 8.1 rotational kinematics. So this is the things that we have seen on a Monday. We are going to go through it very quick to see what does it mean by angular displacement, what does it mean by angular velocity, and also angular accelerations. So angular displacement, well, if you look at the definition, it's very long. When a rigid body rotates about its fixed axis, which is the axis of rotation, the angular displacement is the angle swept out by the line passing through any point on the body and intersecting the axis of rotation perpendicularly. So basically, it tells you the angle. Okay, the angle is the angular displacement. That is all you have to know. Okay, you don't have to go and memorize the complete definition. Angular displacement, it means the angles rotate by one particles. Okay, because if you look at whole object, it is very hard for you to determine the angles of rotation. So you just look at one particle. For example, you take this point, and then after it rotates, you have the delta theta. So it has a change in the angles. So this is very important when it comes to the angular displacement. One revolution is equivalent to one cycle. And one cycle is equal to 360 degrees, and it is equal to 2 pi radian. So for all of the values that involve angular displacement, the SI unit must be in radian. Okay, it must be in terms of radian. So you have to know how to convert the unit. So sometimes questions will ask you how many revolutions. Then you have to know how to convert from radian back into revolutions. So from revolutions to radians times, you use times 2 pi radian. From radian goes back to revolutions. Basically, you just have to divide 2 pi radian. So angular velocity. So angular velocity, well, same as chapter 2, there are two angular velocities that you have to know. One is average, and of course, other than average, we have instantaneous angular velocity. So average angular velocity is defined as the angular displacement divided by the elapsed time, means the time taken during which the displacement occurs. So basically, when it comes to average value, you must have an initial point and a final point. So you can see the object is traveled from one point to another point. So average angular velocity is equal to final angular displacement minus initial angular displacement divided by the time taken to travel from initial point to final point. So the equation is equal to delta theta over delta t. So SI unit, well, just now we say the SI unit for angular displacement is radian. So when it comes to angular velocity, since you use angular displacement divided by time, so the SI unit would be radian per second. Okay, now, other common sense unit in questions in the exam is revolutions per second and revolutions per minute. Sometimes it won't give you a full sentence, okay? Sometimes questions will just give you RPS. So RPS stands for revolutions per second. So revolutions per second is not SI unit. You cannot use it in your calculations. In order to use it in your calculations, you have to change it to 2 pi radian per second. Okay, so revolutions per minute is 1 RPM. The short form is RPM. Okay, R revolutions, P per M minutes. So RPM, 1 RPM is equal to 2 pi over 60 seconds. Why? Because to change 1 revolutions to radian, you have to times 2 pi. And then to change minute into second, you have to divide by 60 seconds. So in order to convert the unit from 1 RPM to radian per second, you use times 2 pi divided by 60 seconds. So how to determine the direction? Well, this is a very important thing. Students always have a misconception. They thought the directions of rotation is the directions of angular velocity. But in fact, it is not. The directions, how are you going to determine directions? You have to determine it by using your right hand. Okay, your right hand. 4 fingers, you curl it towards the directions of rotation. And thumbs represent the directions of angular velocity. So basically, angular velocity is always perpendicular to the directions of rotation. Okay, 4 fingers, You follow the direction, you carry towards the directions of rotation, and then thumbs represent the directions of angular velocity. Question 7 asks you to determine the directions, but you have to know because sometimes it might come out in objective questions. Again, not subjective. Subjective, so far I've never seen any questions asking for the direction, but objective questions it might ask. All right. So other than average angular velocity, the more important ones would be instantaneous angular velocity, which is the angular velocity at any given instant, or a more familiar terms would be at any particular time. So meaning that it happens at just one moment. So why is it so important? Because this is the velocity that we are going to use in our equations. If you look at the equations, the 4 equations, it's asking for initial and final. Means it is asking for instantaneous angular velocity at initial point and instantaneous angular velocity at final point. So that is the main difference between average angular velocity and instantaneous velocity. Instantaneous velocity, you look at one particular moment, whereas average, you must have 2 positions, one initial and one final. Okay, now just now we say whenever you want to calculate, you want to analyze a rotational motion, we are just going to select one particle. Then does it valid? Can we use it for all the other particles? Of course we can. Why? Because all the particles, all points in a rigid body is going to rotate with the same angular velocity, regardless of which point that you are using. So since every position in the objects move through the same angles in the same time interval, they all are going to have same angular velocity. Okay, so average angular acceleration, well, we have average velocity, definitely we're going to have average acceleration. So average angular acceleration is defined as the change in angular velocity divided by the time taken, the elapsed time. So alpha equals to omega final minus omega initial divided by the change in the time taken. So it is equal to delta omega over delta t. So what is the difference between instantaneous and average? If you are just going to look at instantaneous, then you're going to calculate omega 1. If you want to look at the final, then you're just going to use omega 2. But when it comes to average, then you're going to use omega 2 minus omega 1. So maybe initially, because the object just doesn't move, it has a lower angular velocity. Then it increases its angular velocity into omega 2. So omega 2 is larger than omega 1. So therefore, in order to calculate average angular acceleration, you use final minus initial because you have 2 different angular velocity at 2 different times. Okay, so the main difference is, the main difference between average and instantaneous. Average, you have initial and final. Instantaneous, you're just going to look at them one by one. Okay, you're not going to look at both of them at the same time. So as a unit for angular acceleration, same as the angular velocity just now, you're going to use radian in your SI unit. So radian as -2. The sign convention is positive. Angular acceleration is positive if angular velocity is increasing, and it is negative if the angular velocity is decreasing. It's very obvious, right? Because you use final minus initial. If it increases, definitely you're going to get a positive value. If it decreases, then you're going to get a negative value. Let's talk about the directions. The directions, you are not going to determine it by using right-hand rule anymore. You're going to look at it whether it is a positive or a negative value. So if it is a positive value, then it will have the same directions with the angular velocity. Then if it is a negative value, then it will pointing towards the opposite directions. Okay, it will in the opposite direction of the angular velocity. So this is a diagram. So alpha and omega are in the same direction if it's speeding up. Alpha and omega will be in the opposite direction if it is slowing down. Okay, the rotational motion is slowing down. Instantaneous accelerations, it is the angular accelerations at any given instance or at a particular moment. So alpha is equals to d omega over dt, but usually we just use omega over time. Since it is the same for all points of rotating object, alpha will be the same for all points. So as a angular velocity, just now we say every particle inside the rigid body is going to move with the same angular velocity. Therefore, when you use that angular velocity to calculate angular acceleration, they all are going to have the same angular acceleration as well. Okay, so just now is just an introduction to the new terms. Now we're going to look at this table. This is the most important thing in this chapter because it tells you how to convert a variable, a quantity from linear into rotational. How to link these two things together. So the relationship between translational, which is a linear motion, and a rotational motion. In a translational motion, we have distance or displacement, which uses the symbol S, and S are unit in meter. In rotational motion, we use angular displacement or angular distance, okay, where the symbol is theta. SI unit for theta is radian. So how are you going to combine them together? Basically, it is very simple. When you want to join linear motions and rotational motions together, you just add a radius in the relationship. So linear motion, distance, rotational motion, theta. When you want to link them together, you just use linear motion equals to R times rotational motion. That's why you have S equals to R theta. Okay, S equals to R theta. Whereas when it comes to velocity, linear velocity, we have symbol V. Angular velocity, we have symbol omega. When you combine them together, as you can see now, you have linear equals to R times rotational. V equals to R times omega. Okay, whereas for accelerations, linear accelerations, or we call it tangential accelerations, it uses a symbol AT. Angular accelerations, we use alpha. When you want to join them together, you have another linear equals to R times rotational. A equals to R alpha. Okay? Okay, now, if you look at this table, I use AT for linear accelerations, but most of the times you don't have to include T. Okay, I just put a T here so that you can see the difference between these three accelerations. So another term that you will see in this chapter is the centripetal acceleration. Because like I told you just now, every particle in a rigid body, okay, other than rotational motion, is going to move in a circular motion. So definitely it's going to have centripetal acceleration. So centripetal acceleration, it has another name known as radial acceleration. Okay, so AC you have learned in your chapter 6 is equals to V squared over R, and it is equals to R omega squared. So AC, you can calculate it by using linear motion, or you can calculate it by using rotational motion method. So when you combine these two together, well, actually every particle in a rigid body is moving with two different accelerations. So one of them you can consider it as X component, and one of it you can assume it as a Y component. Why? Okay, tangent shows acceleration. Tangent shows the work it means it is always tangent to the circle. So what does it mean by tangent to a circle? It means that it is perpendicular to the radius. Okay, so the direction of tangential acceleration is always perpendicular to the radius. Whereas centripetal acceleration is always parallel to the radius. It's overlapping with the radius. Therefore, the angle between tangential and centripetal acceleration is 90 degrees. Okay, they are perpendicular to each other. Therefore, you can just assume one is the X component and another one is the Y component. So in order to calculate the total linear acceleration, or we can call it net acceleration, or we can call it resultant acceleration as well. So in order to calculate total linear acceleration, you have to use the resultant vector equation. So A net equals to square root AC squared plus AD squared. So that is how you calculate resultant vector. Why? Because you have one on the x component and one on the y component. Okay, so far, any questions? No questions? Good. So the relationship between translational motion and rotational motion, so we have seen them variable by variables. Now we're just going to replace the variables, okay, replace the variables in the 4 linear equations that you have learned in chapter 2. So accelerations in chapter 2, we use A. In chapter 8, we use alpha. Okay, so just now we say velocity V, we replace it with omega. So initial velocity U, we are going to use omega naught. Okay, so whereas as displacement, we are going to replace the symbol with angular displacement symbol theta. So as you can see here, V equals to U plus AT. We have omega, okay, because V is equivalent to omega and equals to omega naught plus alpha t. T, you can keep it because time, it won't change regardless of whether the object is moving in linear motion or rotational motion. T would still be the same. So you have V squared equals to U squared plus 2AS. How are you going to change it to an equation that can be used in chapter 8? V is omega, so omega squared equals to omega naught squared plus 2 alpha theta. It is exactly the same. You just replace the symbol with the symbols that we use in chapter 8. Okay, so S equals to UT plus 1 over 2 AT squared, where theta equals to omega naught T plus half alpha T squared. Whereas the last equation, S equals to half bracket U plus DT, theta equals to half bracket omega naught plus omega T. It is exactly the same, the 4 equations. The only difference is the symbol used in the equations. Okay, and how to apply these 4 equations? Once again, it is same as your chapter 2. So you list out all of the information, okay, and then see which variables, okay, which is the variables that you want to find, the quantities that you want to calculate. And then you compare with these 4 equations. From there, you choose which equations to use. Okay, so list out semua maklumat, banding dengan soalan, tengok dia nak cari maklumat apa, and then kamu baru pilih equations mana yang nak dipakai. Okay, so far, any questions? Any questions before we proceed to 8.2?